Good morning, students. Welcome to Narayana live classes. So today I am going to discuss physics assignment dated on 17/6/2020. So this assignment comes under the topic refraction at curved surfaces. Refraction of light at curved surfaces. The first question is, if we allow a light ray to pass through the focus, which path does it take? So when the light ray falls on any curved surfaces and the light ray which is incident ray is passing through the focus, after refraction, which path that refracted ray takes place? That is the question. See, so I take one convex curved surface. So when the light ray is incident on the curved surface, after refraction, the light ray is parallel to the principal axis. The light ray is parallel to the principal axis. So after refraction, the path of refracted ray is parallel to the principal axis. So that is the first question. Then we can go for the second question. Question number 2. So when an object is placed at the center of curvature, when the object is placed at the center of curvature on the principal axis, what is the nature of the image? What is the nature of the image? So this is the question. When an object is placed at the center of curvature on the principal axis, what is the nature of the image? So we have to consider one curved surface, and the curved surface is having principal axis. So the center of the curved surface is pole. So next, and it is having center of curvature. When we keep an object at the center of curvature, let this object is this, right? So when we keep the object at the center of curvature, name it as AB is a object. So when we keep the object at the center of curvature, we have to form the image, we have to draw a ray diagram. To draw the ray diagrams, we have to consider minimum two light rays which are coming from the object. So one light ray I am considering which is parallel to the principal axis. When the light ray is fall on the curved surface which is parallel to the principal axis, after refraction it must pass through the focus. After refraction it must pass through the focus. So another light ray I am considering which is passing through the principal axis. Another light ray I am considering which is passing through the pole, So when the light ray which is passing through the pole cannot deviate. So I chosen two incident rays. After refraction, when the light ray is incident to the principal axis, after refraction, it will pass through the focus. When the light ray which is incident or pass through the pole of the curved surface, it cannot deviate. So after refraction, if we extended those, they can be intersect at one point. So curved surface means it is nothing but a lens I am considering. For example, lens I am considering. So the thickness of the lens is very less. So that's why we are considering that lens as a single refracting surface. Why? Because the thickness of the lens we are assuming as very much less. So when they are intersected, mark a point. From that point, draw a normal onto the principal axis. From that point, draw a normal onto the principal axis. So it is also center of curvature. C1, C2, F1, F2. Lens is having two center of curvatures and two focal points. So wherever we keep the object, that means we kept the object at center of curvature. The image also we are getting at the center of curvature of another side of the lens. And if we observe the object and the image, image is real image, and the image is inverted at the center of curvature. So when an object is placed at the center of curvature on the principal axis, what is the nature of the image? The nature of the image is real, inverted, and it exists at the center of curvature, and the image size must be equal to the object size. So image size is equal to object size. How much of object is there? Image also is having the same size. So image size is equal to object size. Image size is equal to object size. We can get, if we keep the object at center of curvature, we can get the real, inverted, equal image size. Okay. So this is the second question. Next, we can go for the second Roman letter. Question number 3. Question number 3. So question is, what are the rules to be followed? What are the rules to be followed to draw ray diagrams? What are the rules to be followed to draw ray diagrams for image formation by lenses? So to draw the ray diagram is nothing but which represents the image, object, everything in graphical representation, right? So to draw that ray diagrams, we have to follow certain rules. Those rules are, first, we have to choose the point on the principal axis where should we have to keep the object. That means at infinity, or just beyond the center of curvature, or at center of curvature, or between the center of curvature and the focus, or between the focus and the optic center, right? So like this we have to choose the point on the principal axis where should we have to keep the object, right? So first point is choose or select the point on the object, select the point on the object, select the point on the object, place it at the point on the principal axis. So we have select the point on the object, place it at the point on the principal axis. Where should we have to keep the object on the principal axis? We have to choose that point. Next, draw two rays. So next point is, from the object many light rays are coming. So in that many light rays, one is which is parallel to the principal axis, one is which is passing through the optic center, one is which is passing through the focus, another one is which is inclined to the principal axis. Different situations are there. From those situations we have to choose any two rays. We have to choose any two rays. So draw two rays that was chosen by us. That were chosen by you rays from different situations. So different situations are nothing but, one is which is passing through the optic center, which is passing through the normal, which is passing through the principal axis, which is parallel to principal axis, which is inclined to principal axis. These are different situations are there. From those situations we have to choose any two light rays. So draw two rays that were chosen by you, rays from different situations, right? Next, after refraction, extend those rays. After refraction, extend refracted rays. Extend refracted rays that refracted rays must be intersect to each other. So after refraction, here we are choosing the two rays. After refraction, they can be intersect to each other. So next question, next point. Identify that intersection point, comma, from that point draw a normal onto the principal axis. Identify that intersect point, comma, from that point draw a normal onto the principal axis. Draw a normal onto the principal axis. So that normal is nothing but a object size. That normal is nothing but a image size. That normal is nothing but a image size. First we have to choose where we have to keep the object on the principal axis. First step. Next, from the object many different rays are coming. In those rays situations, in those rays, we have to choose any two rays. Third, after refraction, we have to extend those rays. When we are extend those refracted rays, those two rays must be intersect at some point. Identify that point. Draw a normal onto the principal axis from that point. That normal which is we draw onto the principal axis from the intersection point is nothing but a image. Is nothing but a image. Right? So this is the question number 3. Next, we can go for the question number 4. Question number 4. So the question is, what happens when parallel rays of light, what happens when parallel rays of light fall on a lens, making some angle with the principal axis. So what happens when the parallel rays of light fall on lens, making some angle with the principal axis? What I said, if we keep the object on the principal axis, many number of rays are coming from that object. So if all the incident rays are parallel to the principal axis, all the rays fall on the lens and those incident rays are making angle with the principal axis. Then what happened? See here. First I will draw the ray diagram. I am considering the one lens. So biconvex lens I am considering. It is having the principal axis. So it is the optic center. So two center of curvature C2, F2, F1, C1. So lens is having the two center of curvatures and two focal points. Why? Because it is bounded with the two curved surfaces. So what? Parallel rays are incident and the parallel rays are making some angle with the principal axis. So for example, so these are the incident rays. All should be parallel to each other. And they are making some angle with the principal axis. After refraction, what will happen? So after refraction, all must be intersect at a point. On the focal plane. All must be intersect at a point on the focal plane. Focal plane is perpendicular to the principal axis. This is the focal plane. Focal plane is perpendicular to the principal axis. So what happens when the parallel rays of light fall on a lens, making some angle with the principal axis means after refraction they must be converged. All should be gathered at one point. They should be converged at a point on focal plane. See, This is the focal plane. Focal plane is the perpendicular to the principal axis. All should be converged at a focal plane. Suppose if we consider here the diverging lens, that means if we consider the biconcave lens, after refraction, all should be diverged from a point which is lying on the focal plane. If lens is concave, the refracted rays must be diverged from a point on focal plane. They must be diverged from a point on the focal plane. If it is a convex lens, all should be converged at a point which is lying on the focal plane. So this is the question number 4. Next, last question, Roman letter 3, question number 5. Question number 5. The question is, explain behavior of certain light rays when they are incident on a lens. So explain behavior of certain light rays when they are incident on lens. So different situations, as I said in the what are the rules follow, we have to draw the ray diagrams to find the image. So I said that we have to choose the two rays from the different situations. So that we are going to discuss now. So just I am going to consider a lens is a convex lens. The symbol for the convex lens, simply we can make it as like this. Simply. Or we can draw like this also, no problem. But this is the symbol for the biconvex lens. So this arrows indicates bulged outwards. See here, it is bulged outwards. So now every lens is having the optic center, two focal points, two center of curvatures, So first case is behavior of certain light rays. So I am considering incident ray is passing through the principal axis. When the incident ray is passing through the principal axis, there is no deviation after refraction. There is no deviation means it goes in a straight line, no deviated. So light ray passes through the principal axis. So this is first one. So second, remember here, whether it may be convex or concave, whatever it may be, if the light ray passes through the principal axis, it cannot deviate, whether it may be convex lens or concave lens also. Next, F2, C2, F1, C1. When the light ray passes through the optic center, when the light ray is incident through the optic center, it cannot deviate. Light ray passes through the optic center. Light ray passes through the optic center. It cannot deviated. Next, case number 3. Case number 3. So light ray which is passes through parallel to the principal axis. When the light rays incident on the lens are parallel to the principal axis. See, these light rays are parallel to the principal axis. After refraction, all must be converge at the focus point. All must be converged at the focus point. After refraction, all must be converged at the focus point. So when the light ray passes through the focus or focal point. Suppose if we consider in case of concave lens, all should be diverged from the focus point. Why? Because concave lens will be act as a diverging lens. Next, suppose our fourth situation. Suppose the incident rays all should be passed through the focus. All should be passed through the focus. So all should be passed through the focus. See, all are going through the focus point. After refraction, opposite to this one, if the light rays are parallel to the principal axis, after refraction they must be converged at the focus. If the light rays are all should be passed through the focus after refraction, opposite to previous case, all should be parallel to principal axis. All should be parallel to principal axis. If you want, even though you can consider 2 more rays, no problem. All should be parallel to principal axis. So these are the different situations when the light ray is incident on the lenses. And if in case of convex lens, if the light rays are whatever, all should be parallel, even though the diverge from the focus point. After reflection, all should be parallel to the principal axis. But when we are drawing the ray diagrams, these arrow marks are very, very important. Even though if we draw the correct ray diagram, if we not get the arrow marks, it is very, very wrong. Right? So arrow marks should be very, very important. So these are the explanation for the today's assignment. Thank you all. Thank you.